Hello class. Today's video lecture will be on chapter 5, titled Equations from the Business Mathematics text. There are many slides here, so I'm going to try to get through all of them as quickly as I can, so that we can make sure that it all goes within the reasonable time frame for this video lecture. Some of the learning outcomes are to solve equations using multiplication or division, solve equations using addition or subtraction, solve equations using more than one operation, solve equations containing multiple unknown terms, solve equations containing parentheses, and solve equations that are proportions. So now we're going to get into a little bit of algebra in this chapter. Solve equations using multiplication or division. An equation is a mathematical statement in which two quantities are equal. Solving an equation means finding the value of an unknown. And just to give you an example, 8x equals 24. To solve this equation, the value of x must be discovered. Division is used to solve this equation. Or what you could do, and it's my way of doing it, is you know that 8 times something equals 24. So if you know it, then you have the answer right then and there also. So you can just say 8 times 3 is 24. Letters such as x, y, and z represent unknown amounts and are called unknowns or variables. The numbers are called known or given amounts. So then the given amounts is this 4 and the 16 because it's what you know. The one you have to solve for is usually going to be the variable or the unknown, in this case, which is x. So again, using the same technique that I mentioned in the previous slide, 4 times something equals 16, and if you know it off the top of your head, you would know 4 times 4 equals 16, so x is 4. Any operation performed on one side of the equation must be performed on the other side of the equation as well, and remember that this is as it relates to multiplication or division, okay? Don't consider this just yet for all other types of problems, but for multiplication or division, an equation must be performed on the other side as well. If you multiply by 2 on one side, you must multiply by 2 on the other side. If you divide by 3 on one side, you must also divide by 3 on the other side. So here's an example, 8x equals 24. This first step is to isolate the unknown value and determine if multiplication or division is needed. So this is the long but correct way to do it, and it's good to know this way in case you have to solve it step by step in one of the subsequent exams in the next module. The second step is to use division to divide both sides by 8. And the last step is to simplify, so x would be 3. So find the value of a in this problem right here. A over 3 equals 6. So now you know that 3 goes into a certain number 6 times. And to solve for a, multiply both sides by 3 to isolate the a. The left side becomes 1a or a. The right side becomes the product of 6 times 3 or 18, right? So then that's another trick there. You already know 3 times 6 is 18, so then it also happens to fit for this one. Another example is 2b equals 40. Determine which operation is needed, division. The second step is to perform the same operation on both sides, so divide both sides by 2. So then what this means is that you would divide this by 2, and then divide this by 2. So then what this does is it cancels out these two, and then if you split 40 in half, you get 20. So then what does b equal? B equals 20. Okay, that's it. Isolate the variable and solve. So then b equals, so then it's what we put up here. B equals 4 divided by 2, which equals 20, and that's it. Solving equations using addition or subtraction. Adding or subtracting any number from one side must be carried out on the other side as well. Subtract the given amount from both sides. Would solving 4 plus x equals 16 require addition or subtraction of 4 from each side? And it would require subtraction. So then what you would do to get the x on its own is to subtract 4 and then subtract 4, and then 4 minus 16 is 12, and that should be your answer. Next example here, 4 plus x equals 10. The first step is to isolate the unknown value and determine if addition or subtraction is needed. So here it looks like we're going to need subtraction. So subtract 4 from this side, and then subtract 4 from this side, and then this cancels out, x is by itself, and 10 minus 4 is 6. Okay. Use subtraction to isolate x, and then see, the answer is 6. b minus 12 equals 8. So now in this example, since this one is a negative already, to get rid of this 12, you would have to add 12 to it. So then addition would be required. So then what you do to one side, you must do to the other side. And then what do you figure the answer is going to be? 20. Okay. And then it fits because you can check with scrap paper or with calculator that 20 minus 12 equals 8. The longer way to do it is to first determine which operation is needed, and in this case is addition, which we did. Perform the same operations to both sides, so add 12 to both sides. So a negative 12 plus 12 equals 0. So then actually what this does is it cancels out, leaving the b by itself on one side. So b equals 8. B equals 8 plus 12 rather, which is 20. And then the last step is isolate the variable and solve. Solving equations using more than one operation. Isolate the unknown value. Add or subtract as necessary first, then multiply or divide as necessary second. Identify the solution. The number on the side opposite the unknown. Check the solution by plugging in the number using the original equation. And plugging in is really good when you're trying to double check to make sure that you've got the correct answer. When two or more calculations are written symbolically, the operations are performed according to a specified order of operations. First, perform multiplication and division as they appear from left to right. Second, perform addition and subtraction as they appear from left to right. To solve an equation, undo the operations working in reverse order. First thing you want to do is undo the addition or subtraction. Next, undo the multiplication or division. As an example, we have 7x plus 4 equals 39. The first step is to undo the addition by subtracting 4 from each side. So let's do that. And you do minus 4. And then remember, this cancels out. That's why we're doing it minus 4. And then we do minus 4 on this side. And it's going to be 35. Okay. So then this leaves us with 7 times something equals 35. So we know off the bat 7 times 5 equals 35. So, but let's move along with the rest of the steps. The second step is to divide each side by 7 to get the x on its own. So then you would, the example is telling you to divide 7x by 7 to get rid of the x. Divide 35 by 7 to get 5. But we just did it the shortcut way. And the third step is to verify by plugging in 5 in place of x. So 7 times 5 is 35 plus 4 is 39, and it works. Solving equation containing multiple unknown terms. In some equations, the unknown value may occur more than once. The simplest instance is when the unknown value occurs in two addends, such as 3a plus 2a equals 25. Add the numbers in each addend, 2 plus 3. Multiply the sum by the unknown, 5a equals 25, and then you solve for a, and in this case, a equals 5. So basically what they did here is they took the numbers in the addend 3 and 2, just added them together, that equals 5, so then it just becomes 5a equals 25. Okay, so here's an example. Find a if a plus 4a minus 5 equals 39. The first step is to combine the unknown value addends. So here we have a plus 4a equals 5a. 5a minus 5 equals 30. Step 2 is to undo the subtraction. 5a equals 35, and we know that we already know that 5 times something 7 equals 35. Third step is to undo the multiplication, so a equals 7, and then you can check by replacing a with a 7. So then we have 7 plus 4 times 7, and 4 times 7 is 28, plus 7 is 35. Solving equations containing parentheses. Eliminate the parentheses. Multiply the number just outside the parentheses by each addend inside the parentheses. Show the resulting products as addition or subtraction as indicated, and solve the resulting equation. So as an example, we're going to solve for 6, and then in parentheses you have a plus 2, and then equals 24. The first step is to multiply 6 by each addend. So 6 multiplied by a plus 6 multiplied by 2. And then what that equals is 6a plus 12. 6a because 6 times a equals 6a, plus 6 times 2 equals 12. And then you just reworked the problem getting rid of the parentheses. And the third step is to check by replacing a with 2. So 2 plus 2 is 4, and 6 times 4 is 24. Another example, 5x minus 2 equals 45. So again, you want to follow the same method right here. The tip, remove the parentheses first. So then you have 5x, because 5 times x equals 5x, and then 5 times negative 2 is negative 10, equals 45. Then what we do next is, remember, we have to isolate this one, so then you want to add 10, and then when you add 10, this cancels out, and adding 10 to 45 is going to equal 55 down here. So now you have 5x equals 55. So if you already know multiplication off the top of your head, you can say 5 times 11 equals 55, and there's your answer. Or you can take it a step further and then divide it by 5 to get rid of this 5, and then put the 5 under here, and then you get 11 either way. Solving equations that are proportions. A proportion is based on two pairs of related quantities. The most common way to write proportions is to use fraction notation, also called a ratio. When two ratios are equal, they form a proportion. A cross product is the product of the numerator of one fraction times the denominator of another fraction. An important property of proportions is that the cross products are equal. Verify the two fractions form a proportion. Does 4 over 12 and 6 over 18 form a proportion? The first step is to multiply the numerator from the first fraction by the denominator of the second fraction. So then you actually do like an x, right? You go 4 times the 18, which equals 72. And then the second step is to multiply the denominator of the first fraction by the numerator of the second fraction. So then coming up here, you do 12 times 6. And then in the first one, it equals 72. And then in the first one 72, second one 72. So are they equal? Yes, they do form a proportion. Learning outcome for section 5-2, use the problem-solving approach to analyze and solve word problems. Use the problem-solving approach to analyze and solve word problems. The first 5-step problem to solving approach. 5-step problem-solving approach. What you know are the known or given facts. What you're looking for, unknown or missing amounts. Solution plan, equation or relationship among known or unknown facts. Solution is to solve the equation, and conclusion is interpreted with context of the problem. So then this is going to be the real world application of business math to actual situations here. These are keywords in table 5-1, which will guide you in using the problem solving approach. You got addition, subtraction, multiplication, division, and equality. And so addition, these are all terminologies consistent with addition, subtraction, multiplication, division, etc. These words help you interpret the information and begin to set up the equation to solve the problem. As an example, of often implies multiplication, so a quarter of her salary means multiply her salary by a quarter. Full-time employees work more hours than part-time employees. So this is using a solution plan. If the difference is 4 per day and part-time employees work 6 hours per day, how many hours do full-timers work? What are we looking for here? The number of hours that full-time employees work. So that's the solution. We're going to get the number of hours. What we know is that part-time employees work 6 hours, and the difference between full-time and part-time is 4 hours. So now we're setting up a solution plan. So full-time minus part-time equals 4. Full-time equals, we're going to say n, which is the unknown, and part-time equals 6 hours. So now n, which is the unknown, this can be x or anything else you want it to be, n minus 6 equals 4. We also know the difference implies subtraction, so that's why we're doing n minus 6 equals 4. So now the solution would be this. N equals 4 plus 6, which equals 10. So the conclusion is that full-time employees work 10 hours. Here's another one. Jill has 3 times as many trading cards as Matt. If the total number both have is 200, how many does Jill have? So now the key word I'm looking at here is 3 times as many. So guess what we're going to do? 3 times as many as Matt. So if Matt has X, Jill has 3 times as many. So what are we looking for? We're trying to find out the number of cards that Jill has. That's going to be our answer. What we know is that the relationship in the number of cards is 3 to 1, and the total is 200. So now we're going to set up a solution plan. So we do X times the number of cards Matt has plus 3X in parentheses Jill's cards equals 200. So automatically, like just to give you, before we move on to the solution, the way that I'm looking at this problem is that Jill has 3 parts of the cards that Matt has. So she has 3 out of 4 of the total amount of cards, and Matt has 1 out of 200. So I'll get back to that in a second when we move forward with the solution plan. The last one is to solve it. X plus 3x equals 200. 4x equals 200. And then x equals 50. So now you draw the conclusion. Jill has 3x, or 150 cards. So this is what I was talking about, right? I look at it like a circle. And if this circle equals 200 cards, 200. Jill has 3 parts of this. Matt has 1 part. So remember the proportion, which is this one. So then if you divide up the sections, Jill has 3 parts and Matt has 1 part. So then 200 divided by 4 is 50. So 50, 50, 50, 50. So I divided it into quarters. Jill has 3 of those, which is 150, and Matt has 50. So that's just another way of conceptualizing the how to solve for it, just because the problem fits. Here's another one. Diane's card shop spent a total of $950 ordering 600 cards from Wits & Co., whose humorous cards cost $1.75 each, and whose nature cards cost $150 each, $1.50. How many of each style card did the card shop order? What are we what are we looking for? How many humorous cards were ordered and how many nature cards were ordered? The total of H plus N equals 600, or N equals 600 minus H. If we let H represent the humorous cards, nature cards will be 600 minus H, which will simplify the solution process by using only one unknown, which is just H. So what do we know from the problem? We know that the total was of $950 were spent, and 2 types of cards were ordered. The total number of cards ordered was 600. We also know that the humorous cards cost $1.75 and the nature cards cost $1.50 each. So now here we set up the solution plan. Set up the equation by multiplying the unit price of each by the volume represented by the unknowns equaling the total amount spent. So now we have here $1.75 humorous cards, and then $1.50, and then 600 minus H, which are the unknowns. Unit prices, we have that, and the total amount spent. For the solution, we have $1.75 H humorous cards plus $1.50, and then parentheses 600 minus the humorous cards, totaling 950. $1.75 H plus 900 minus $1.50 H, because remember, we do this, remember, $1.50 times 600, $1.50 times H, and that equals 950. And then we have 25 cents plus 900, and the reason being is because since looking at this section right here, you have H and you have H right here on both sides, so you can subtract $1.50 here. It's actually $1.50 H, and then $1.50 H from the subtracted from this side as well, and that leaves you with 25. So 25 cents H plus $900 equals 950. So now we're getting closer. 25 cents times H equals $50. And if you multiply 25 cents times 200, you get 50. So your answer is H. So the conclusion is that the number of humorous cards ordered was 200. Since nature cards are 600 minus humorous cards, we can conclude that 400 nature cards were ordered, because we know from the problem that there were 600 cards ordered. Using 200 and 400 in the original equation proves that the volume of the amounts are correct. Here's another. Denise ordered 75 dinners for the awards banquet. Fish dinners cost $11.75, and the chicken dinners cost $9.25 each. If she spent a total of $756.25, how many of each type of dinner did she order? So now what we know There were 75 dinners ordered. $11.75 was the fish cost, and the chicken was $9.25. And we also have the total. Okay, so we have $11.75 fish. We have $9.25, and then we have here that 75 dinners total minus fish equals $756.25, which is the total amount. So now we start to work out the problem. We bring this down. So $9.25 times 75 dinners is $693.75. $9.25 times F equals $9.25. F equals that. We just bring that down. So now we have to isolate, and then we do that by getting rid of 925F, and then when you subtract it from this side, you're left with $2.50 F plus $693.75 equals $756.25. We're still bringing that down. 250 F equals $62.50. So F is 25, and we can check that by plugging it in. So the conclusion is that 25 fish dinners and 50 chicken dinners were ordered. And see, the cool thing about this is that you're able to solve it without the need of knowing how many fish dinners or how many chicken dinners you got. The total amount is the most critical number in trying to determine this. So it's a pretty cool approach, so you don't have to like add every single dinner to try to figure out different combinations and whatnot. Proportions. The relationship between two factors is often described in proportions. You can use proportions to solve for unknowns. An example is the label on the container of weed killer gives directions to mix 3 ounces of weed killer with every 2 gallons of water. For 5 gallons of water, how many ounces of weed killer should you use? The first step, what are you looking for? We're looking for the number of ounces of weed killer needed for 5 gallons of water. What we know is that for every 2 gallons of water, we need 3 ounces of weed killer. So now we set up a solution plan. Okay, so we put 2 over 3 equals 5 over x. So why this? Because for every 2 gallons of water, we need 3 ounces of weed killer. So for 5 gallons of water, how many ounces of weed killer? So then to solve it, we cross multiply. So 2 times the x equals 2x. 3 times 5 equals 15. And then x equals 7.5. Because what you do is, as you recall from previous slides, you have to isolate the x. Divide by 2, this crosses out. And then same here. Divide by 2. And when you divide 15 by 2, it equals 7.5. So the conclusion is that you'll need 7.5 ounces of weed killer for 5 gallons of water. Many business-related problems that involve pairs of numbers that are proportional involve direct proportions. Increase or decrease in one amount causes an increase or decrease in the number that pairs with it. So as an example, if your car gets 23 miles to the gallon, how far can you go on 16 gallons of gas? And this is an example that I use whenever I have to drive from like Broward to Washington, D.C., for example. I know that my car consumes 32 miles a gallon on the highway, so I try to figure out how many times I have to refuel. So with 1 gallon, you get 23 miles. So for 16 gallons, how many miles do you get? That's what we're trying to solve. So you cross multiply 1 times x equals 1x. 23 times 16 equals 368 miles. And 1x is the same as x. Because if you divide 1x by 1 to get rid of the 1 in the 1x, and you divide 368 over 1, you still get 368. So you can travel 368 miles on 16 gallons of gas. In this example, an increase in the amount of gas would directly and proportionately increase the mileage yielded. Learning outcomes, evaluate a formula, find an equivalent formula by rearranging the formula. Evaluate the formula. Write the formula, rewrite the formula substituting known values for the letters of the formula. Solve the equation for the unknown letter or perform the indicated operations applying the order of operations. Interpret the solution within the context of the formula. So as an example, a plasma TV that costs $2,145, which, not anymore, now they're a lot cheaper, is marked up $854. What is the selling price of the TV? So use the formulas S equals C plus M, where S is the selling price, C is the cost, and M is the markup. So S is your answer, which is going to equal 2,145 plus 854. S, or selling price, equals 2,999. Find an equivalent formula by rearranging the formula. Determine which variable of the formula is to be isolated or solved for. Highlight or mentally locate all instances of the variable to be isolated. Treat all other variables of the formula as you would treat numbers in an equation. And perform normal steps for solving an equation. If the isolated variable is on the right side of the equation, interchange the side so that it appears on the left side. So as an example, the formula for square footage equals the length times width, or S equals L times W, which we just shortened. Solve the formula for W, or width. Isolate W by dividing both sides by L. So the new formula you're going to have is S over L equals W. And this concludes the 5th chapter of the business mathematics text. As always, if you have any questions, comments, or concerns, please feel free to email me at kletamen@broward.edu, and I'll be more than happy to assist. Thank you, and have a great day.